I'm Rob. This is my dog Bella. She wanted to be in the video as well. In March 2019, I was supposed to be attending CSUN Assistive Technology Conference, where I was due to be speaking about some of the changes that SwiftUI has brought and some of the ways that that improves accessibility in iOS apps. Unfortunately, because of COVID-19, I wasn't able to attend that conference and I wasn't able to speak. So I thought I'd make a version of the talk and upload it to YouTube. So I hope you find it useful. All of this talk is based on some blog posts and guides that I've written on SwiftUI and how that makes accessibility much better. And that's all available at mobileally.com. It's mobileA11y.com, and you'll find a section for SwiftUI guides there. Hope you find the talk useful.
I also have a book available, Developing Inclusive Mobile Apps. It covers how to build accessible and inclusive apps for both iOS and Android. It's available to order now from apress.com.
Today I'm going to talk about accessibility in SwiftUI. If you didn't already know, SwiftUI is a brand new way of creating user interfaces using Swift code on Apple platforms. Apple announced it at WWDC in 2019, so it's still a really new technology. This is one of the older ways of making user interfaces on Apple platforms, on iOS specifically. These are called storyboards, and it's a layout of screens which you can use, as here we've kind of used a wireframe approach, but you can use them to add in your text and images as well and place those exactly where you want them. It allows you to do layout and make sure that it works on different screen sizes, and allows you to place interactive elements like buttons and controls and things like that as well. This is what SwiftUI looks like. SwiftUI is all done in code. There is a kind of WYSIWYG element to it, but the user interface itself is all built up using code like this. So SwiftUI is really new. It's less than a year old at this point, and it's something that a lot of people aren't using yet in production just because it's so new and there's still a few questions about how it works. So there's obviously a question about, well, if it is so new, why are we talking about accessibility already? Maybe we need to sort out some of the other questions we have first. I want to answer that using this podcast. Now, this is a podcast as part of the Parallel feed. It's actually a 40-minute long audio documentary created by Shelley Brisbane. It's called 36 Seconds That Changed Everything, How the iPhone Learned to Talk. And it's the story of how the iPhone became accessible. Here's Phil Schiller on the stage at WWDC announcing the brand new accessibility features on the iPhone. And the reason it's called 36 seconds is because that's how long Phil Schiller was talking about these new accessibility features, and these were really the first accessibility features that were part of the iPhone, that were part of iOS. And this documentary, I've clipped it here at 19 minutes and 27 seconds of a 40-minute long documentary halfway through. The reason I clipped it halfway through is because this is exactly the point in the documentary where we start talking about Phil Schiller announcing the new accessibility features on the iPhone. So this proves that although these accessibility features are incredibly important to people, although they mean the difference between being able to use the iPhone and not being able to use the iPhone, it was just as important to people who need those features that they weren't there. Half the documentary, the first half of the documentary, covers the difficulties that some people had in using the iPhone before it was accessible. So I want to play you some quotes from this documentary now.
I remember picking up a friend's iPhone and feeling this blank piece of glass, essentially, with just a button on the bottom of the glass, thinking, man, we are going to be locked out of this thing, and it's a real concern.
I was sad because I felt, oh, here's another time we're going to be left out, and eventually someone's going to come along and make a special blindness-specific eye device. It'll be 3 versions old. It'll cost 4 times as much, and we'll just keep buying it because it's the only option that we have.
For the first time in 20 years, Apple had built a product I couldn't use. I'm fairly sure I cried about that.
It was heartbreaking to me. I actually held someone's iPhone in my hand, and it was the most beautiful, sexy, sleek device. It was just flat. I mean, I don't know how else to describe it. As a blind person, it was just flat. And then this beautiful backing and curved. Oh, man, if it could just say one thing to me, if it could just, but it couldn't.
All of these quotes from the first half of the documentary, before the iPhone became accessible, really show that people who need to use these accessibility tools are really no different to the rest of us who use the iPhone. They all love the design, the beautiful attention to detail that Apple put into these products. And they really want to use them just as the rest of us want to use them. It's just that because of some of the design decisions made in the early iPhones, they weren't able to do that. Now, the iPhone is now accessible. It's generally considered to be one of the drivers for accessibility in a lot of modern electronics. The UIKit Accessibility API, which drives a lot of this, is really fantastic. It allows tools like VoiceOver, which reads the content of the screen and lets people with no or very little vision control their device. It also controls the screen reader, which will read large portions of text. If you have a web page or a book in this instance, someone can just set the screen reader to read that content for them, which is really fantastic. Again, if someone doesn't have great vision, or if someone struggles to read perhaps. It allows switch control so that people with very limited movement can use an external switch to navigate and control their device. And voice control is a brand new feature in iOS for this latest release. And that allows people, again with very limited movement, to control the iPhone just by using their voice. It's very cool to use as well. UIKit's Accessibility API is great, but it will only ever be an add-on, because it was something that wasn't considered when iOS was first built. Considering accessibility from the very start results in a better product. And that's exactly why I want to talk about accessibility in SwiftUI right now. Just before we go any further, just a little bit about me. My name is Rob. I am an iOS engineer. I currently work for Capital One in the UK. I also have a blog. I edit a blog, mobileally.com, mobileA11y.com. And there I collate a lot of information about how we can build apps for iOS and for Android that are more accessible, that allow more people to use them and include more people in them. You can contact me as well on Twitter or by email. I'm always really fascinated about people's experience with accessibility on mobile devices. So whether you use it, or whether you know someone who uses it, or whether you're a developer who makes apps for iPhones or Android phones, and you've had a good or a bad experience creating something with accessibility, I'm always really interested to know. So feel free to get in touch. SwiftUI, as opposed to UIKit, was created with accessibility as a first-class citizen. Apple built it with accessibility in mind from the very start. They did it by including people from Apple's accessibility teams along with a lot of the people who were making SwiftUI. And a lot of these accessibility decisions can really be seen throughout the syntax of SwiftUI and some of the decisions that have been made. SwiftUI works with accessibility out of the box. It keeps your accessible user interface in sync with your visual user interface, and we'll cover this more in just a second. It encourages best practices by forcing you to consider how you use images. in your interface. And it promotes good accessibility. Text is all multi-line and all supports dynamic text sizes by default. You actually have to write more code to make your app less accessible. So before we move on to some of the changes that you can make, I think it's important just to very quickly consider why accessibility in SwiftUI is a much better option. This on the right here is the user interface for an app that I've built. It allows people to book holidays to various places around the solar system. This is the listing page for Mars. We've got a hero image at the top. We've got a title and subtitle. We've got a like button. And then we've got some detail about the holiday. We've got a switch so people can get notified of updates about that holiday. And a big button to let them book that holiday to Mars. The price there, I googled it. It is roughly accurate to send 4 people to Mars. Don't know if anyone's got $6 billion available, but you can enjoy a trip out there if you have. So this collection of images and text, buttons, controls, you'd recognise this, right? This is your user interface or visual user interface. This is what you see when you use really any iPhone app. But your app also has an extra user interface that not everyone will be familiar with. And that is called, or Apple call it, the accessibility user interface. You might be familiar with this on other platforms where it's commonly known as the accessibility tree. It's essentially the same thing. And the accessibility tree, or the accessible user interface, is this extra user interface that isn't visual, but that represents all of the content that's on the screen, all of the controls and text and images and all that kind of stuff. And it includes information about how that is presented to different assistive technologies. The accessibility user interface on iOS is generated for you. You have no direct input to it. You can't ever see it. And you don't directly create it. It's built for you by Apple's Accessibility API as part of UIKit, based on the visual UI that you've created in your storyboard file, or in code, or however you're generating them. But it's something that you don't directly interact with. It's used to communicate with assistive technologies such as VoiceOver, switch control, braille keyboards and voice control, and many others. But the accessibility user interface is customizable. Although you don't interact with it directly and don't create it directly, you can give UIKit some hints as to what you want it to do with it. If it doesn't generate it for you perfectly based on the information from your visual user interface, you can tell it, hey, make this change. We need to improve that. I'm going to give an example here of what would make up a accessible user interface. Now, as Apple don't ever provide this interface to you directly because it's not something you as a developer can really interact with or create yourself. And that's kind of deliberate because we want it to be really basically exactly the same as your visual user interface. So instead, this is kind of an artist's rendition of what a accessible user interface might be. We'll build this up by navigating through this screen with VoiceOver, and on the left hand side I'll kind of print out what I think the information that makes up the visual user interface, the accessible user interface, might be.
Mars. Image. Mars. The red planet. Heart. Image. With virtually zero cloud cover. Send me updates. Switch button. Off. $6 billion for a family of 4. 7 nights. Plus 80 days travel. Book now. Button.
There we go. That's roughly what an accessibility user interface might be. We've got the type of object and we've got a text value for it. But there's a few other things that we'll want to add in. So, for example, actions, so that people who are using switch control or voiceover know that they can interact with a particular element. So where we've got a button, we'll add in an action so that if somebody does choose that with switch control knows what action to call. We also maybe want to specify something in terms of order. For example, this hero image at the top, and we've got above that we have our title and subtitle and our like button. And we want to make sure that our accessibility tools will always access that in the order we intend. So we'll want to tell it that we should access the Mars title over the subtitle, and that those are really connected, and then say that actually after the title and subtitle we want to connect the like button to that, and we want to make it clear that that goes above our hero image so that when it's highlighted with a bounding box, the bounding box knows where to draw. So we'll add that layout information in as well. And actually what we've kind of done here is we've basically created SwiftUI. This code that I've kind of given you as an example as to what an accessible user interface might be, well, this is just SwiftUI code. And this is why SwiftUI is such a fantastic option for accessibility. SwiftUI separates the what from the how. It takes what we want to be presented to the customer, so text, a control, the order it's connected in, the control's actions, and how that's presented to our customer. So, for example, we can present it as an iPhone screen. One of the extra benefits of SwiftUI is that it makes it really easy to present that same user interface as an iPad screen or a Mac screen as well. But also, as well as having SwiftUI create you a screen for a Mac application and an iPad application and an iPhone application, well, SwiftUI can also create you an interface that voice control or voiceover or switch control can use as well, just by taking that what information of we want a button and we want some text. This really comes into its own with state. Now, in this example, we've loaded the hero image and title, but we're going to the network to find out some information about this holiday, and we're waiting for that information to come back from a network request, so we phone up a spinner while we're waiting for that. So if we were to access this screen in VoiceOver, this is what we'd hear.
Mars. Image. Mars. The red planet. Heart. Image. In progress.
So that's pretty much what we'd expect. So now, this is again our UI kit example. The spinner has disappeared because the content has returned from the network. Now, in UIKit, sometimes you can get a mismatch between information on the screen that's displayed and information that's provided to the accessible user interface. And this happens if you make a big change to the screen like this, where we've replaced the spinner with some other content. So in UIKit, sometimes we'll get a bug that's a bit like this.
Mars. The red planet. Heart. Image. In progress.
So you can see what's happening here. Although visually we can see on the screen we've got a bunch of extra text content, VoiceOver is focusing on a progress spinner that is no longer actually visible on the screen. And that's happening because VoiceOver hasn't been told by UIKit that the screen has actually changed. Now you can fix this in UIKit by posting this notification, UI accessibility screen change notification, and that will tell UIKit that it needs to tell the accessibility user interface to update based on new content. But we don't always remember to do that. Maybe we don't know we need to do that because we're not VoiceOver users. So sometimes this catches us out. And it means that VoiceOver users can never tell what content is actually on the screen, or maybe they can, but it's very confusing because the accessibility user interface will catch up eventually, but for a little while it will look like there's no content there. Well, in SwiftUI, this isn't a consideration at all. We can completely forget about all of this. And that's really because of this very first line that you have in SwiftUI. In fact, it's really about the very first word there, struct. So this is very basic Swift knowledge, but structs in Swift are value types. They are non-mutable. So when you create a struct, the values that you give it when you create it are the values that that struct will have for its lifetime. Except UI doesn't work like that. In UI, we're creating and changing things all the time. We're adding new elements, we're maybe animating something, we're maybe changing text. So how does that work with a struct? Well, that means that SwiftUI has to recreate a new struct every time. So this is what happens. The value on the struct changes, and that triggers the struct to be recreated by SwiftUI. And so that means that SwiftUI is going to redraw the screen based on the new information it has. But because it's doing that at the same time, it can also automatically trigger the accessible user interface to redraw. Which means your visual user interface, what you can actually see on the screen, will always be 100% in sync with what's presented to accessibility tools. So you're never going to have this mismatch between what's visible and what's presented to accessibility users. Images are another great improvement in SwiftUI. SwiftUI makes all images accessible by default, and it will take, as the accessibility text, the name of your image. So here, this image command for SwiftUI will load from our asset catalog an image called M1 hero image at 3x, which makes perfect sense for managing our assets. But if a VoiceOver user navigates to that, what they'll hear is M1 hero image at 3x. Well, that's meaningless to one of our users. So in this situation, we'd need to add an extra label to it. This label is then what is read to our customer. There is another option as well. The other option you can use is this one here. Say we've fetched information from the network as part of a network request, but unfortunately something went wrong, there was an error. So we've added in an exclamation mark image to let our customers know that something went wrong. We've also added the image, added text as well, because you always need to provide information in a redundant manner. So people who can't see the colour, the red colour of the exclamation mark, can still read the word error, still makes sense to them. Well, if that image is called error, then this is how VoiceOver would present it.
Error, image. Error.
VoiceOver has now just said the same thing twice, which is kind of frustrating because it means you've added an extra swipe and you've not really given any extra information. This means that it's going to be really laborious and time consuming for the VoiceOver user to navigate and use your app. It's going to be incredibly frustrating for them. So the option here is to use what's called a decorative image. Now, we still pass it the file name or the name of our asset catalogue of the image we want to display, but we preface it with the word decorative. And that means VoiceOver will ignore this image for us and just read the text. Let's talk about controls. So controls are things like buttons and switches and sliders, anything that you can interact with. So let's take a look at this example.
Send me updates. Switch button, off.
So this again is UIKit. This is a common issue with accessibility in UIKit, in that many controls, like toggle switches for example, don't have text associated with them. So this is a switch that someone can toggle this to receive notifications if something changes in this image. And visually we can see that send me updates is to the left of the switch. So we can see that if we toggle that switch, it's going to send us updates. That makes perfect sense. But what if you can't see the layout? You can't infer that contextual information if all you can hear is voiceover. Take a listen. First of all, we'd have to swipe to the label.
Send me updates.
And then we'd have to swipe again.
Switch button. Off.
We know there's a switch button, and we know it's off. But what does the switch button do? What's going to happen if I turn that on? Well, because you can't see the layout, you can't guarantee that that text we heard before, send me updates, is what's going to happen if we toggle that button. It could be that actually the button is above the text describing what actually that switch button will do. Now, that isn't the case in this instance, but for a lot of users who use VoiceOver, it's a common thing that they come across, and so they're naturally going to be wary of toggling a button that they don't know 100% what it's going to do, because it might do something they're not expecting. Well, in SwiftUI, this is completely fixed. Really, all controls in SwiftUI take a text value in the control's body, which links the control directly to that text. So listen to this one.
Send me updates. Switch button. Off. Double tap to toggle setting.
It's really clear and obvious exactly what that control does then. It's one swipe, which makes it quicker, simpler and easier to navigate. And we've got the name of the control in there. So anyone who toggles that is going to know exactly what that toggle does and know what they're going to expect from it. Let's talk briefly about semantic views. So semantic views are kind of a slightly more advanced technique in terms of making your apps more accessible. And it's not something that everyone will be aware of, so I'll just give a very brief introduction to it. So this is an example of a semantic view from within iOS that you might come across if you use VoiceOver. So this is a message bubble in iMessage. If VoiceOver was just focusing on the content, then the bounding box would just be pretty tightly drawn around the message of, do you want to go for dinner or a movie? Well, actually, that's not really the meaningful part of this user interface. The meaningful part is the message bubble. And so that's exactly what VoiceOver has highlighted here. It's not drawn the bounding box tightly around the message, but around the message bubble, because that's the meaningful part of the UI. Now, semantic views are a view that contains meaning. So here, the meaning is, this is a message. In this instance, the semantic view just has one piece of content, the text, but really semantic views can contain multiple elements. So you can contain multiple bits of text, or text and a control, or various other pieces of UI in there as well, but together they really have one meaning. There was various ways of doing this in UIKit, but SwiftUI makes it incredibly simple. Layout in SwiftUI is all built up using stacks, H stacks, V stacks, Z stacks, and you can put elements inside these stacks to group them together and to specify to SwiftUI what order and in what position you want these elements to be. Here's an example of an H stack from our holiday app, which includes 2 bits of text and a button. Now, if we present that to VoiceOver like this, this is what VoiceOver will provide to our customer.
Mars. The red planet. Heart. Image.
So that was 3 swipes there, one to Mars, one to the red planet, and one to the button. But actually, really, these probably make sense as one. It's a title and a like button. It's kind of the topmost part of the screen. We want to present it as one thing. It's only got one action, and the like button really gets its context from the title. So if we put those together into a semantic view, that will make it much easier to navigate and much more meaningful. And in SwiftUI, we do that just by adding this one modifier, accessibility element children.combine. And that tells SwiftUI to combine all of these elements, all of the child elements, the text and the button, into this one H stack. That means that those three elements are no longer presented to accessibility, but what is presented to accessibility is all their information combined as one. So let's listen now to what VoiceOver presents to our customer.
Mars. New line. The red planet. Button. Image.
It's so much simpler. It's one swipe, and we've got all the context and information that we need to know exactly what that button does. So techniques like this are going to make navigating your app so much simpler for anybody using assistive technologies. So that's SwiftUI accessibility. Accessibility in SwiftUI is great. And the reason I think we should be talking about it now is because I'd really love to encourage you to use SwiftUI. Next time you're starting a new app, consider using SwiftUI, because not only is it a nice, cool new technique, but your accessibility users are going to get a much better environment as well. Again, if you have any thoughts on accessibility in mobile, please feel free to contact me. You can get me by email or on Twitter. I also run mobileally.com, mobileA11y.com, and that has a whole guide on accessibility in SwiftUI where we cover all of the topics that we've covered in this talk in much more detail, and a few others as well. So visit mobileally.com if you want to know a little bit more. Thank you very much.